Thanks, guys. Thanks for coming here. I'm Matt Matthews. I run the product management team, and I'm going to go through a couple slides. And the good news is that that's probably the rest of the slides that you'll see today. We're going to go right from my talk into really demos, and we've told the guys here that are presenting after me, don't use any PowerPoint, right? Just go right to demo. So the rest of the day will really be about product stuff. So I thought it'd be useful, just because some of you guys haven't necessarily talked to us before, seen us before, to give a brief history of Plexi in kind of we're kind of in our what I call Plexi 3.0 phase right now. So what was 1.0 and 2.0 about? So we started, about 5 years ago, 5.5 years ago. You kind of saw where we started over there in the office. We spent about a year and a half raising a lot of money and building our IP. Right, that was really kind of the first gen of the product. And culminating in, you can see we actually, we started, a couple of us, we raised initially a round. Right after that, we raised a B round, and you can see it was kind of exciting news. We also got a Twitter handle that was like, $20 million in Twitter handle went together.
Twitter handles are up to $20 million?
Yeah, exactly. Raised another 20 million soon after that, and then that culminated about a year later, where we essentially did our first launch of the technology, and the focus was on what we called affinity networking. I kind of view that as the first discussion of what's now in vogue of intent-based networking, because we were talking about workloads, understanding workloads first, understanding those requirements, and our concept of SDN was that a controller was built to take those requirements and turn that into underlying network details, right? That was really what we did. We also started to talk a little bit about our switch at that point. And unfortunately, a lot of the focus went into the switch in terms of the optics and stuff like that, because that's what people picked up on. And that's kind of what people remember about us. But really, it's the switching infrastructure, and we'll talk a little bit about that today, is really for us very much a how. We did, and I went back to our trip down memory lane here. We spent a lot of time in 2.0 at NFDs, so 5, 6, and 7. We spent a lot of time in some of these talking about things like freeing the wires and making sure the physical layer is dynamic and things like that. So our Plexi 2.0 is really about bring some scale to our solutions, hardening the designs, really going for kind of prime time deployment. So in order to do that, we had to go reach back into legacy installations and make sure that we were doing enough of the legacy world to bring our customers forward. So we had denser switches. We actually came out with some new non-WDM designs. So the switches that you see here have embedded optics in them, and then we also came out with solutions that don't have embedded optics, or that have embedded optics but that don't use WDM technology. We also came up with solutions that don't have embedded optics at all, quote unquote bright box solutions. So off the shelf switching that can also provide this dynamic fabric under software control. So we are really agnostic to the physical layer. Our point is that it has to have some capabilities that allow us to make those decisions in software that are really important to the workloads. So this is really about what Plexi 2.0 is about, and we kind of culminated this in July of last year with our launch of the Plexi Switch 2 and the 2E, which is the Brightbox-based solution. So we announced the whole family at that point, and our control plane was way more robust and scalable, and that's really what we focused on in the market with our customers, getting them deployed. We're now in Plexi 3.0, and so you'll start to see us really kind of honing in on what is the specific use case drivers that make a customer want to look at Plexi. So even though we have a very full-featured networking solution at this point that's scalable and robust, we want to target the customers that are heading into kind of this Platform 3 era. So this is really the focus that we have now, which is what we call the cloud builder. The cloud builders are people that are building clouds, right? Their focus is on what the infrastructure can do for me, not on the constituent silos and finding the best port speeds or the speeds and feeds games from a network perspective, right? They're focused on the overall infrastructure and making it productive for them. And as part of this, we are following the cloud as well in terms of what they need. So connectivity-wise, they do need 25 gig switches, those are coming up, and we have also been spending a lot of time on how do the cloud guys automate their infrastructure. And for us, automation is a little bit different from what most people might talk about from a networking perspective, and you're going to see a lot of that today. In the past NFDs, we talked about a prototype concept that we called DSE. We have now productized that as Plexi Control and Plexi Connect. You're going to see that very much featured today, and really focused on hyperconverged and IP-SAN types of integrations into our fabric, because really what we're seeing is as people, again, come off a fiber channel into IP-SANs and they try and converge those IP-SANs with their data network, or they take a hyperconverged network, they run into these issues, and this is where we can really help them. And we're going to start talking a lot more about multi-workload support, and I'll spend a few minutes on that in a second. But really that brings us up to today. So we launched our Plexi Connect product yesterday. That is GA now, and again, you're going to see a lot of that today. It ships with our VMware and Nutanix integration packs, and we have a lot more integration packs that are in development right now. We have our Switch 3 EQ, which is our 25 gig switch. We'll be shipping shortly in a couple of weeks. And we have a big focus right now on lots of storage vendors, lots of hyperconverged vendors, big data, and orchestration systems from an integration perspective. So the point of this is that we see that Platform 3 is happening. We see the guys that are building converged cloud infrastructures. They're leveraging these new storage and converged infrastructures to make it simpler for them, and they want to drive everything from that top-down perspective. So we want to give them a data plane that's really dynamic and is responsive to workloads. It can handle multiple workloads simultaneously. We want to give them a control plane that doesn't let them get down in the weeds about flows if they don't want to. If they want to, it has that capability, but really elevate the abstraction up to workloads for them. And then we want to give them an automation plane that lets them understand what events are happening in their data center and program policies around that. So a quick background on our product set. Obviously we have switches, we have a control plane, and we have Plexi Connect. So Plexi Switch, all of our switches they're like iPhones. So Switch 1, Switch 2, Switch 3. We're on the Switch 3 generation now. We're not going to talk about much of this today because we've spent a lot of time in the market talking about those. We're going to talk a fair bit about Plexi Control because that's what drives everything. It sits in the middle, so you're going to see that featured fairly frequently. And then we're going to talk a lot about Plexi Connect and the integrations that we're doing and this concept of event-based workflow automation. The thing to remember about the switches is, again, our goal here is to make this fabric as dynamic as possible because our control plane relies on having lots of levers. And those levers are all the internals of networking, all the resources that the network should provide to workloads. So that could be, you might hear things like TCAMs or layer 2 tables or layer 3 tables or links that have different characteristics of bandwidth or latency on them, right? Or buffers, for example. All of these things are resources that are hidden in these switches that a user shouldn't care about. If I have a big data app and it needs something, that's what I should be able to say, not I need blah, blah, blah for buffer space and I need these TCAMs programmed and blah, blah. So that's, our controller is designed to translate that. And in order to do a good job of what we call fitting, which is taking your workload needs and turning it into those lower layer stuff, it needs as many levers as possible. So in addition to what most off-the-shelf switches give you, which is a little bit of programmable table space that you can go move flows around, our switches are designed to let you move the wires, let you change the layer 2 table space, layer 3 table space, optimize all that from the control plane, which handles all that, and it basically has all those levers at its disposal. So that's really what you need to know about our physical switches. I'm happy to answer any questions, but our focus is really on the other two. Again, Plexi Control is our control plane. Our focus on the control plane, again, is giving a user a workload-based abstraction. So if you can tell our controller what your workload is and what it cares about, it can turn that into the network resources that workload needs. And ultimately, all of that telling of the controller has to be automated. So this is why we have Plexi Connect. And we didn't want our users to have to go and just take what they would normally do manually in Plexi Control and automate that as a bunch of scripts. Because our network can also react dynamically to different workload events and things like that. We wanted to make it very simple for a user to capture events that are happening in their data center and create actionable policies based on those. So Plexi Connect is really designed around this concept of events. We talked about this already, but again, when we talk about the fabric itself, we differentiate between single-purpose networks, which are highly optimized, InfiniBand, fiber channel. There's been, in networking, there's been ATM and frame. All these things have been designed to be really around a specific concept, and they generally use very expensive componentry to kind of achieve what they're doing from an SLA perspective. Ethernet came over and kind of ruled the world in terms of being a good it was good enough at everything, and it was cheap to implement and deploy. It used fairly low-cost componentry, and so it became really simple and easy to build, operate, and maintain, right? But in this new world, what we're seeing is that you need a bit of both, right? You need the low-cost aspects of this. You want to leverage the low-cost componentry, the fact that everybody understands Ethernet and IP. You don't want to learn special network transport. Specialized network transport, but you want to take some of these attributes of single purpose. You want to say when a workload needs something, a specific SLA or specific fabric capability, that you can do that. You can carve out some fabric capabilities for it. So that's really what we're focused on, is building this notion of a multi-purpose type of fabric at that layer. And just some examples. So this is a best practice diagram that is, you'll see this in a lot of our competitors' literature. For example, for deploying a non-converged IP SAN type of environment, right? So generally what they'll say is if you really want deterministic performance, what you'll do is you'll carve out some of your spine switches and your leaf switches over here and put your IP storage arrays on those. And all your compute hosts will basically be cross-connected, just like you would kind of do in a SAN. You'd have your compute nodes connected both to themselves, their own network, as well as to the SAN network, right?
We storage guys don't trust the network guys.
Yeah, that's another reason. And the other option, if you want to converge everything, you have to kind of start thinking now about designing everything for the worst case, right? So notion of deep buffer switches. Now you need deep buffers everywhere, right? A good analogy in this is, if you're driving on a highway, we have this all the time. A big box store opens somewhere on one exit, and all of a sudden there's a line of traffic trying to get off that exit, right? A deep buffer solution is, building an exit ramp that winds around a few times before it gets off, before it drains, right? That's the concept of deep buffer. Imagine if you had to build those exit ramps everywhere just because you had one big box store at one place. And now imagine if that big box store would randomly move around and show up in different places. That's the concept that you had to get to with these kind of architectures, right? And so when storage is everywhere in these hyperconverged environments or these fully converged IP SANs, we don't see this as a workable solution. We need to have a fabric that leverages that kind of single uniform capability across everything, but leverages the capabilities of the fabric to do things differently. So this is just a simple example for rack type of data center, and this kind of mimics some of the demo stuff that you're going to see in a lot of ways. So the first thing we want to be able to do in this type of environment, in here we have some vHosts, so some virtualization hosts, and that have their own dedicated IP storage. There's 2 racks like that, and there's 2 racks that just have hyperconverged. The first thing I would want to do in a Plexi network is basically automatically detect and isolate the storage subsystem traffic, right? Because when this was on its own dedicated storage system, all the metadata, rebuild, cluster trap, all that kind of stuff was hidden from me. It wasn't out on the network. Now it's all over here. So I want to be able to automatically detect that stuff and build its own isolated, protected paths so it doesn't get impacted and it doesn't impact other people. The second thing I want to do is be able to identify these events that happen while I'm operating my data center. So again, this notion of event-based automation. So a simple example is a live VM migration, right? If I'm doing a storage V migration from here to here and I have to drag my storage across with it, I'm going to generate a lot of network bandwidth all of a sudden, right? So it would be really good if the network would understand that event's happening and allocate some dedicated but temporary bandwidth for that during that event, so it doesn't it doesn't slow down and it doesn't impact other people while it's in process. You can see a similar thing happening in the hyperconverged space. The notion of a cluster rebalance happens a lot. If you take out or remove a node, that file system has to be striped now across all the remaining members in the cluster. Generates a lot of traffic. So that's something that you would want to detect as an event that happens and ensure there's adequate capacity in that part of the fabric, and then release it when it's done. And then you have this notion of the actual workloads themselves. So in this simple example, you have 3 types of workloads: an OLTP workload, VDI workload, and a big data workload. And these might have different criticality for the user, right? OLTP might be their mission critical workload, and its policy might be, I get first access to, I get first dibs, right? I'm generally sensitive to latency, so if you have the lowest latency links, give them to me first. If you have undersubscribed or lowly subscribed links, give those to me first, right? That's kind of an example policy that you might say for your OLTP workload. Give me the priority access to the least utilized, lowest latency paths. But I also have this VDI workload that, 9 o'clock in the morning, everybody shows up, and we got this boot storm because I've got golden masters that are being replicated across. So detect that when that's happening, and give me that for that period of time. Give me some access to bandwidth so I can support my VDI cluster. And then you have this big data workload, which might be completely best effort, right? It's a marketing guys are running web analytics overnight. It's going to take, instead of taking 4 hours, I don't care if it takes 5 hours. HDFS should have access to bandwidth when it needs to do an ingest or some type of replication. But in general, if I need to steal that bandwidth for something more critical, make sure I can do that. So this is an example of what we call a multi-workload fabric. Leveraging Ethernet, commodity components, nothing specialized in this. But I understand that there are special workloads that need special things at special times, and there are events that happen that need, at that time, they need what they need. And again, you're going to see a lot of this in the demos. I've talked about event-based automation. It's a very simple concept. You're probably hearing it out there a lot. All the systems that people are building in data centers today generate events. And that's great because we can use that information. We can sit on a message bus and listen to those events. And that's essentially what Plexi Connect is doing. It's listening to events, and it gives the user a very simple way to create action triggers. If I see this, go do this, right? So what Plexi is doing is we're building this Plexi Connect product again, which is, again, GA yesterday. We GA'd this version of it, the Connect Enterprise. We're going to have a DevOps version out early next year. And the point of this is to provide this message bus where we provide users that capability to write these simple, they're defined in YAML, these simple policies that define what events I want to look at and what actions I want to do. And we are actually building a lot of these integrations ourselves, a lot of these infrastructure integrations. We are understanding what events are generated from those and understanding what impact they might have on the network and creating essentially shrink wrap policies that go and implement a fabric response. Of course, those are customizable, but we want users to be able to have a turnkey approach when they're integrating a VMware Cloud or a Nutanix system, Hortonworks or whatever, right? The DevOps version, like I said, is coming later next year. You're going to see us talk about some of this stuff in here, but really what we're seeing is customers that might like the concept of turnkey, but they're very customized. They have their own workflows, they have their own idea of what they want and how they want to integrate, and they want full access to customize everything, right? There's this notion of DevOps and ChatOps that you might hear out there a lot. So the folks that are trying to build infrastructure as code are leveraging all the developer tools, whether it's Git or Jira or Bitbucket, Slack, HipChat. All these types of tools are now being used to automate the infrastructure. And the DevOps shops out there really want to be able to build their own hooks into the tools that they use in the workflow that they use. So we have a number of these integrations that we're working on and that are available now and that we're working on. So again, we focus on a lot of these infrastructure, software-defined infrastructure systems. So Rich mentioned a lot of them. So Nutanix, vSAN, Scale.io, NetApp Cluster ONTAP, all these things that are kind of distributed file systems or cloud, big data types of things, HDFS that create events. Those are the integration packs that we're mostly focused on. Our users might have their own workloads that they want to create their own integrations around. And then again, the community, we're actually leveraging an open source project for Plexi Connect. And so there's a community around it that's heavily invested in building a lot of these DevOps and ChatOps capabilities that you'll see here. I'm going to skip over this. One of the other things you're going to see today is this notion of per workload traffic virtualization. So we couldn't give you a multi-workload fabric without letting you as a network operator see what's going on. And in fact, you may not even be the network operator. This information may at some point be exported to the tools that you use if you're the virtualization administrator or the storage guy or the converged infrastructure guy. So this is a simple screenshot. You're going to see some more advanced visualizations from Eric later. But the point here is that I want to be able to see in my fabric what's using what, or what's allowed to use what, how those things are layered on top of each other. And you can see this now feeding into real-time statistics, so you can actually see what parts of your fabric are more heavily utilized than other parts of your fabric, and what are they being utilized by. What specific workloads are leveraging more of the fabric. This is a heat map that's built into our latest Plexi Control GUI. And you're going to see a little bit of this interspersed throughout the demos as well. So again, this notion that if I'm a DevOps shop, I have my own workflow. We actually, some of you may have been, Ethan may have been at the Bossnog thing where we demoed this, but you'll see pieces of this again today. This message exchange is essentially our Plexi Connect message bus. And in this example, we showed a customer that wanted, they had a workflow around when new VMs came online, they wanted to be able to verify the distributed virtual switch configuration. So they had a workflow that basically, in Slack, they could basically type a command that said verify DVS, and in Slack would go and tell, Slack would go do some checking in vCenter to make sure that the virtual switch was configured with LDP versus CDP. If it wasn't, it would change the config. And that whole workflow was represented in a Kanban board in Trello. So you would actually see something show up in an in-progress queue when a job was kicked off. You could actually put an additional, approve, reject kind of workflow around that, but you could see it progressing through as the automation progressed. So again, you're going to see parts of this in the demos today. And then if we have time, if not, we're going to do this over lunch, but we have some cool stuff that we'll geek out over later. Basically, because our network is heavily modeled, again, our goal is to make sure that the resources in the network are available to the software layer. All the resources, whether it's the wires, the TCAMs, the buffer, whatever it is, right? So we model everything in the network. And when we model things, we can now access them via software, via APIs. So a lot of what our controller does is leverages those resources behind the scenes because it knows what it has and what the capabilities of those resources are. But we can also do some fun stuff like put a graphics engine on top of it and do some 3D visualization because we can see all those resources. So we're just going to show you some of that cool stuff that we have in the works.